Hey everybody, welcome back. It is lesson 3.7 formulas today. I'm going to do a little tape lesson, see how it goes. Today we're going to be solving a formula for one of its variables. So in the past we've solved for x and y when we were given 2 or 3 step equations or multi-step equations, but now we're going to throw in a little bit of a twist. Instead of it just having one variable, some might have two, and you're going to solve for one variable. Okay, I'll show you what I'm talking about in just a second. Very first thing is we're going to have a couple vocab words. First one is going to be formula. So pause your video right now. Write that down because it does have that beautiful yellow bar. Okay, so pause now and write this down. So what a formula is, it is an algebraic equation that relates two or more quantities. And some formulas that you have seen in the past, area we've talked about, perimeter we've talked about. We're going to talk about definitely area today, about different shapes. But also maybe in science you've talked about converting Celsius to Fahrenheit or Fahrenheit to Celsius. We're going to talk about that again, or talk about that today as well, and other formulas. So I want you to write down a couple formulas that you need to know, that I really want you to know. One being the temperature formula, another being the area of a triangle. So please pause now and write these down. Okay, pause now. All right, so temperature formula, when we're dealing with temperatures, we know it deals with Celsius and Fahrenheit. Okay, so C stands for degrees in Celsius, F for degrees in Fahrenheit. So if you plug in, let's say you have, 38 degrees. If it's 38 degrees Fahrenheit outside, you can plug that 38 in for F. Okay, so let's say it's 38 degrees Fahrenheit. You can plug this in for F, subtract 32, multiply by 5/9, and you will get your Celsius. So whatever you know for F, or if you know your F, you can figure out your C. Today what we're going to do is we're going to know our C, okay, and have to solve for F. So it's going to be slightly different on this end, but we're going to be able to do it. Okay, so area of a triangle, I believe you've seen this maybe once, twice, 100 times before, or maybe this is the first time. Okay, area of a triangle is half times base times height, where A is your area, B is your base, H is your height. Awesome. We're going to move on to a couple more. Okay, so area of a rectangle, base times height. I know you have seen that once, twice, or 100 times before. Okay, where B is your base, H is your height, and A is your area. Just giving you kind of a definition of what those are. Density, I'm not sure if you've seen this in science or not, but the density formula is going to be D equals M over V, where M is your mass and V is your volume. Okay, when you think about density, a lot of times it talks about grams over centimeters cubed, or a weight, essentially the unit of a mass over a volume, being a unit cubed. Centimeters cubed, millimeters cubed, feet cubed, so on and so forth. Okay, so you are going to be using the density formula a little bit as well. What I want you to do, make sure you have this written down before you move on. Yellow bar. The last one I want you to write down is going to be the distance formula. We have talked about this a little bit, and again, I don't know if you've talked about it in science, but you do need to know this, so please write this down. D for distance, R for rate, T for time. Alright, so on these equations it says solve for the equation for the indicated variable. Notice there is no yellow bar. I do not want you to write this down, okay, because we're going to write down a couple more on the other side. Now, in the past, we have talked about equations like 3, let's say 3 plus x is equal to 4. So that type of an equation. But notice on this first problem, we have r minus s equals t. And it's telling us to solve for r. Okay, I want you to look at that and notice we're not going to get a numerical number. Okay, we don't know what R is, we don't know what S is, and we don't know what T is. But we are going to use our inverse operations to solve for R. And when I'm talking about solving for R, I'm talking about getting R on one side of the equal sign with everything else on the other side. Okay? Let me say that again. R on one side of the equal sign with everything else on the other side of the equal sign. Okay? It might not be a numerical answer. I will repeat, it might not be a numerical answer. Okay? So we're going to use, just like we did for this 3 plus x, we would subtract this 3, right? Because we would then get x is equal to 1. We would take that and subtract that subtract that 3 because that's the opposite operation to get what x is. We're going to use those same principles on this first equation. So if I have r minus s is equal to t, and according to this equation, it says the indicated variable, my indicated variable is r. So I'm going to solve for r. Now, what that means is I need to get r all by itself on one side of the equal sign. So, what do I need to get rid of? Well, I need to get rid of that s. That s is on the same side of the equal sign as my r. So, in order for me to get rid of the s, I take the inverse operation of what's happening to that s. It's being subtracted. I'm going to add. And I'm going to add s to both sides. Now remember in chapter 2 we talked about combining like terms. T and s, those are two different variables, which means they are two different variables. Okay? Which means we can't combine them. They're not like terms. So our answer is going to be t, r equals t plus s. And I'll make a little weird t here because we have an addition sign there. So t plus s. And I'm done. I brought that s over, I got it away from the side that my r was on, and I solved for the indicated variable. It may not seem like a solve, but I solved for it. I got r all by itself. Nothing else is there. Okay, and that's all we're doing. We're solving for the indicated variable. Alright? Second problem. We have x is equal to half times the sum of y and 4. Okay, so now what I'm going to do is I'm going to get y all by itself. Now, before in chapter 3, we've talked about we need to distribute, we need to distribute, we need to distribute. Okay, in this problem, we could distribute to begin with and then solve for y. Or, instead of taking 2 steps, we could take 1 step, do the 2-step, okay, whatever. Okay, or we could take 1 step and we could get rid of that half right away. Okay, what operation is happening between the half and that y plus 4? It's multiplying. Okay, so it's multiplying together. So what we are going to do is we're going to take the inverse operation of that. Okay, those two are multiplying together. We are going to divide. Okay, so we're going to divide by half on both sides. Divide by half. Okay, if I took x divided by half, remember, multiply it times its reciprocal, and I end up with 2 over 1x times x, which is equal to y plus 4. Or, in other words, 2x is equal to y plus 4. Okay? So now I just got rid of that half sign. That half went over to the left side to get that 2x. Multiplied by the x to get 2x. Okay? Now what I'm going to do, again, I'm solving for y. So I want to get y on one side of the equation with nothing else. So I'm going to, if I look at this, I'm going to see on my right side I have y plus 4. I need to get rid of that plus 4. I want to have y all by itself. Okay? So in order for me to get rid of that plus 4, I need to subtract the 4, just like I would in a previous problem. Okay, so now I subtract the 4. Can I combine 2x and negative 4? Absolutely not. So my answer is y is equal to 2x minus 4. Okay, I don't have a numerical answer. I solve for y though. I got y all by itself. Alright, so we're going to try a couple of problems here. Okay, if you need to rewind, flip back, please do so, and we'll go through. Okay, So if you think you have a good grasp on this, I want you to give these problems a shot. Okay? Or give the first one a shot. If you're not quite sure, just follow along. We'll try a second one. Okay? So pause now and try number 1. Alright, so this first one, we are solving the equation for the indicated variable. That means, if I'm looking at that bx plus k is equal to v, I am solving for this x right here. Which means I want to get x all by itself. Okay, so if I look at that equation, okay, I am going to get rid of what's happening to that bx, or sorry, what's happening with the bx, what's on the same side as that bx, it's that k. Okay, just like if you were given the equation up here, a little sidebar, 3x plus 5 is equal to 14. I want to get rid of this 5 first, right? Same thing down here. I want to get rid of that k first. Okay, it's being added to my bx. Okay, so I'm going to subtract my k. Subtract my k. Okay, so now I have bx on this left side is equal to v minus k on my right side. I took that step, I brought that k over from the left to the right. From left to the right. Now what I'm going to do is I'm going to try to get x all by itself. Okay? So now I have bx. What is happening between the b and the x? Multiplication. Okay, so what do I have to do to get rid of it? Division. Divide by b. Remember, I have to divide the entire thing on both sides by b. Okay, I'm not just dividing the v by b. I'm not just dividing the k by b. I'm dividing everything on that side of the equation, on the right side of that equal sign. So my answer, I'm just going to leave as a fraction of v minus k over b. That is my answer. I just solved for x. Notice there's not one single number in that equation. Doesn't matter. It does not matter. You are solving for the variable, and that's exactly what we did. Okay, if you haven't tried the second one, I want you to pause now, try number 2. Alright, so this one, we're solving for g. Okay, now just like we did in the one above, okay, I want to get rid of what's happening, get rid of everything on one side of the equation, because I want to have g all by itself. So the very first thing I'm going to do is subtract this 4p. Now, I'm going to subtract 4p. Now, you might be asking, why didn't I divide there? Remember, what's happening to the 4p as a whole? It's being added in the problem. Not being multiplied. Multiplication is happening between the 4 and the p, but not to the overall 4p, the expression of 4p. I'm going to move the entire expression of 4p over to that right side. So now I have 5g is equal to r minus 4p. Again, I cannot combine r's and p's. It's impossible. Okay, why? Because they are two different things. So now I have 5g. Remember, I'm solving for g. So I need to get g all by itself. How do I get rid of that 5? Well, what's happening between the 5 and the g? What's happening to that g is being multiplied. So I need to divide. And again, I need to divide the entire equation on that right side by 5. Not just the r, not just the 4p, but the entire equation. So my answer is going to be g is equal to r minus 4p all over 5. It's going to get complex. Notice there's a lot of moving parts here, a lot of moving variables before we are given numbers. Okay, this time I want you to look at this and move variables. Okay, be careful. You're going through the same process as you did before, only this time it's with variables. Make sure if in order for you to combine two things, they need to be like terms. Like terms. Okay? This last one. Okay, it was a lot like that very first one that I did all alone. Okay, it says C is equal to 5/9 times F minus 32. Hey, where is that at? That's our equation for our Celsius. So now we're solving for F. We're solving for Fahrenheit. If I'm given a Celsius degree, I will be able to figure out what it is in Fahrenheit. So here we go. Very first thing I want to do is I want to bring this 5/9 over to that left side. So what is happening between the 5/9 and the expression of F minus 32? It's being multiplied. So what does that mean? I need to divide by 5/9. Okay, divide by 5/9. So I need to take a little sidebar here. C divided by 5/9. Be careful. I am not taking 5/9 divided by C. I'm taking C divided by 5/9. When I flip this and I multiply by the reciprocal, I get 9/5 C is equal to F minus 32. I divided by 5/9 on both sides. Divide, keep, flip, switch, and I multiplied by 9/5. Okay, I did that to the entire C. Now, remember we talked about keeping things as fractions, and I want you to do that. Keep them as fractions. All right, so we have 9/5 there times C. So now I need to get F all by itself. What's the only thing that's stopping me from having F by itself? It is that minus 32. Opposite operation. I need to add 32 to both sides. Add 32 to both sides. And my overall answer is going to be 9/5 9/5 C plus 32. And I'll just start all this over. It's going to be 9/5 C plus 32 is equal to F. And I'm done. Okay, I solved for F. The entire thing, I know I'm like a broken record right now. It says solve for the equation. Okay, we are not going to get numerical answers all the time. In your homework, you're not going to get numerical answers. The first 3 problems will not be numerical answers. Actually, the first 4 problems won't be numerical answers. Okay? So don't let that scare you. Don't let that throw you off. You're still using the same processes as we did in the early chapter 3. Okay? Now we're going to get into a couple of numerical answers. So it says find the height of a triangle that has an area of 25 inches squared and a base of 10. Height of a triangle. I want you to use that formula that we know of triangles and solve. Okay? Pause now. Give it a shot. All right. So the area of a triangle is going to be half times base times height. Okay? We know our area is 25 inches squared. We know that our base is equal to 10 inches. We are trying to find our height. We're solving for that height. Okay? And I'm just going to use h as my height. So, plugging things in, 25 is equal to half times base times height. When I get this all together, I have 25 is equal to 5h. Divide by 5 on both sides. And I get h is equal to 5. Now, I multiplied half times 10. That's how I got 5, because 1/2 times 10, or 1/2 of 10, is 5. Divided by 5, and I have 5. Now, is that the correct answer, though? It's a trick question, Mr. Sheeman. Yes, it is a trick question. I'm glad you said that. Because inches. Don't forget your inches. Inches, 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 inches. Labels, labels, labels. All right, here we go. Last problem of the day. It's been a little bit longer of a lesson, but that is okay. Look at that. I just rhymed. All the time. Okay, here we go. I want you to try this one by yourself. Using that density formula, I want you to solve for the mass. The density formula, solve for the mass. All right, so our density formula is D is equal to M over V, where D is my density. What's my density? It's 11.3 grams per centimeters cubed. Okay, what is my V? It is equal to 0.9 centimeters cubed. What is my M? I have no idea, so I'm just going to use the variable of M. Plugging these things into the equation, I'm going to solve for M. So 11.3 goes in for D. 0.9 goes in for V. Not there. M over 0.9. Okay, so now I need to get M all by itself. I am finding my mass. So in order, what is happening between my mass and my 0.9? It is being divided, so I need to multiply both sides by 0.9. So multiply both sides by 0.9. Okay, if I take 11.3 times 0.9, I get roughly, give or take, M is equal to 10.17. Now the question is, am I done? It's another trick question, Mr. Sheeman. Yes, it is. Oh my gosh, I am so glad you said that. Okay, I'm not sure who said that, but thank you for saying it. Don't forget, we also need our labels again. Okay, labels. What is going to be my mass unit? Okay, if I notice, I have centimeters cubed here. I have centimeters cubed, grams over centimeter cubed. Okay, because that's my label for the volume, that leaves grams as my mass. Done. We're done with notes today. Here is your homework. I want you to show your work. Okay, like always, show your work. Okay, show your work. On page 174 through 176, you're doing 4 through 8 evens, 11 through 23 all, 28 through 34. Now, when you get through 4 through 8 evens, that's going to be where you're solving for an indicated variable. There's going to be several other ones where you're going to, but those 4 through 8 are solely going to be solving for the variable. Okay, so before you do numbers like 13 and 14 as well, just to give you a heads up, you're going to need to solve for those variables, and then you're going to answer the question. So there's going to be 2 answers for 13 and 14. Make sure you answer all the different pieces of the problems. So be careful. Make sure you're reading directions and solving for everything. Okay, I hope you all have a wonderful day, and I will see you later.